Okay, looking at the nth roots of unity. So we're going to look at solving things like Zn equals 1. So here we're going to work out the three cube roots of unity, so solving Z cubed equals 1, which we did previously by changing 1 into a complex number and then moving the power of 3 across the other side, and it's the cube root. In this case, we will do the same thing but see a pattern. So we could change the 1 into the cis of 0 plus k2 pi, which then just becomes the cis of k2 pi. Then if we move the power of 3 across the other side, we end up with a cis of k2 pi on 3. So now if we let k equals 0, 1 and 2, we can get our first three solutions. So if k equals 0, z will equal the cis of 0, and then if k equals 1, we've got the cis of 2 pi on 3, and then if k equals 2, we've got 2 times 2, so 4 pi on 3. Now in this case here, we're asked to express w as the root with the smallest positive argument, which would be that term there. So if cis of 0 we can change to 1. Now we're going to let cis of 2 pi on 3 be w, with the argument being smallest positive value. And then this value here of cis 4 pi on 3, we can rethink that as the square of the cis of 2 pi on 3, using de Moivre's theorem in reverse, because the 2 and the 2 would multiply to give us that 4 there. So in fact this term is now w squared, where w is equal to the cis of 2 pi on 3. Alright, so the next bit, we've done this bit here showing that the roots are 1w squared. I want to show that the sum of those roots is in fact equal to 0. So in this case we can change those complex numbers into Cartesian form. So the first one was 1, the next one was the cis of 2 pi on 3. So 2 pi on 3 puts me in this quadrant here, SATC. The working angle here is pi on 3, and therefore the ratios would be, for the cosine, it would be a half, so negative a half there, and the sine up here would be root 3 on 2. So we can express it as minus a half plus I root 3 on 2. So we've got minus a half plus I root 3 on 2. And the next value was the cis of 4 pi on 3 over here, which puts me down in this quadrant, and both the cosine and the sine are negative, so negative a half and negative root 3 on 2. So we've got negative a half, take I root 3 on 2. So if I were to do 1 plus w squared, I add these three solutions together, so 1 minus a half plus, and if we add those up we can see that the 1 here and minus a half gives 0. We've got the I root 3 on 2, take I root 3 on 2, so we end up with the value of 0. Alright, so we can use the fact that the cube roots of unity are 1, w and w squared, where w is cis of 2 pi on 3, to solve other equations if we can match the two patterns. So in this case here, that's not quite the same as the last question. But if I were to move the negative 1 across the other side, we've almost got the cube root here equals unity. So what I'm going to do here is rewrite this left-hand side as that expression there. And that will be the same, because I've got the z cubed here, which makes the z cubed, and I've got the negative 1 here is cubed, which still gives us negative 1, which is the term we've got there. So the left-hand side is just being rewritten. So that equation there, we can now solve using what we know about the cube roots of unity. So the solutions to this equation here will be 1w and w squared. But it's no longer z equals 1, or z cubed equals 1. It's in fact z on negative 1. This value here has replaced z. So now we can simplify to get z must equal, multiply the negative 1 across the other side, negative 1, negative w squared, and we should write down what w is equal to. W is the cis of 2 pi on 3. Okay, next one. Once again, using the cube roots of unity. So, I want to see if I can make that equation, replace that one there. So, we do have in fact something cubed equals 1. So that something there, that z take 1, is equal to the solutions of this equation here, which is 1w squared. So now z is going to equal, move the 1 across, we add it to all terms, and once again, should write down w is the cis of 2 pi on 3. Okay, so that's using the solutions to that to solve that equation there. Another one here. Once again, if I can show something like z cubed equals 1, I'm going to change that there. I can rewrite 27 as 3 cubed. So z take 1 cubed equals 3 cubed. Now divide the z take 1, sorry, not z, divide the 3 cubed across the other side. So z take 1 cubed divided by 3 cubed equals 1. Put the left-hand side here in brackets with the 1 power of 3 outside. So I end up with that there. And now it matches this pattern here, which means the solutions to the thing in brackets, 1w squared. So z take 1 on 3 is 1w squared. So rearrange all that, which gives those 3 solutions. Once again, where w is the cis of 2 pi on 3. Which should be enough information to get you started on exercise 4F2. You will notice there's a pattern. Whenever you solve Zn equals 1, we're going to work out 1w squared up to the last term will be w n minus 1, and w itself will always equal to cis, and this angle here with the smallest positive argument, there'll be a pattern to it. A pattern linking the n and 2 pi. And I think that's question 3 or 4 in exercise 4F2. Okay, that's enough to start 4F2.